There's a chunk of space in the world carved out. We're giving those corners special numbers on the top left, the bottom right, and the center. We're going to have to calculate how far the eye is back in the Z. I mean, it's still going to be 0, 0 in the X and the Y. The camera is going to be some distance out in this direction, right? We'll have to calculate how far this is going to be. I'm just going to put it here just as a demonstration. So the camera is going to be right here. Let's think about one of these pixels, right? If I were to say, okay, here's the camera movement. I'm going to shoot a ray that goes through this pixel. You can see that, oh, great. If I'm doing that pixel, well, it intersected the sphere right here. So I know it's at least going to be green. So I go ahead and color that one green, right? And that grid of pixels, right? That's not a size in our world. 256 by 256 is not a size. Like 4 by 4 here is not a size in my world. It's just it's a count of the number of pixels. Top left corner is -1, 1. Top right corner is 1, 1, 0. So to be clear, very clear, right? I get this question all the time. If you have to compute the width here, the width is not 4, right? It's not that. It is 4 pixels across, that's true, but that's not the width, right? We've got 2 coordinates here that tells us exactly what we need to calculate the width. The next thing that we really care about here is the field of view, right? I want to know, like, is the camera here and we're looking like with this really wide field of view? Or is the camera back here and we have a more narrow field of view, right? Specifically for our application, we're going to define this ourselves. I care about picking the field of view, so we're going to hold that constant. And what I want is to have a field of view of 90 degrees or pi over 2, right? So how are we going to do that? Well, I'm going to say yellow is the thing we don't know that we're trying to find out. We know we want an angle here, and this angle needs to be 90 degrees. It goes 1 to -1, right? So I don't know if you're familiar with SOHCAHTOA. So tangent, it relates those things. This would represent more pixels, but it's the exact same amount of space. This space doesn't change at all. It's just we're going to cut it up and find enough pieces such that we have 256 going across and 256 going down, right? Right, we've got the camera, which is the eye. That's what this represents. We've got the grid. It's 4 by 4. Yours will be 256 by 256. We put the camera in the right position because we know exactly what the distance is here from the center, right? We calculated that. And now what's really important is if we're going to create a ray that goes through each of these points, well, we need to know what the position in the middle of a pixel is. This is where you have to relate both the number of pixels and the size of this in space. So the size in space is h. 4 is the number of pixels in across. So now what I want to ask is, what is the size of a pixel in space? And that's important because if I know what the size is in my 3D space here, then we can figure out how to get to the pixel's center. Let's say we wanted to get the position of this second pixel right here. What we could do is I could say, well, I'm going to start over here in the top left corner, which I know is -1, 1, and I'm going to add 1 pixel to the right. That takes me to right here. Now what we need to know is half a pixel. And if we know what 1 pixel is, well, half a pixel, right, is just h over 8. So this is an eighth, right? It gets us to right here. Y starts at 1, and we go down by a half pixel, right? H over 8. That gets us that position right there, right? So that if we did 2 minus from, that would have created the vector that is exactly like this, right? It goes from here to there. But we know that when we put it in an array, really this is going to be normalized. So it's going to be something like this, right? That's going to be our array. And now when we do our intersection tests, well, what happens with that? Come out here, you can see that, okay, that hits nothing. Does it look like it hits the green sphere to you guys? I can kind of show you that definitely hits nothing. In the interest of time here, what I'm going to do is cheat a little bit. I'm going to say our sphere, let's say our sphere is right there. Boom, we hit the sphere. Great. So now I know that the sphere, it hits the sphere for 1. And we can calculate lighting, which the guide will go through. And we come up with some kind of green for that. All right, so this pixel gets green. So what do you guys think? Does this make sense? You understand the difference between the number of pixels and the size of this space, this chunk of space that we carved out, our window to the world?
Very cool use of VR.
It is real cool. For me, it's just more of, I have to do it to understand it more.